presented by the Research Institute for the Humanities in the Faculty of Arts at the Chinese University of Hong Kong. I hope all of you who attended enjoyed the day of DH last Friday. I thought it was a really great success. It's the third iteration of that event, and I think every year we go from strength to strength, so that's very gratifying to see. Today we have another normal sort of event in our talk series, but one I've been looking forward to for a while for a number of reasons. So our speaker today is Dr. Luca Scholz, who's a senior lecturer in digital humanities at the University of Manchester. Before this, he held a Mellon postdoctoral fellowship at Stanford, obviously a world-renowned center for digital humanities, and he earned his PhD in history from the EUI in the beautiful Fiesole near Florence. Dr. Scholz's work sits at the intersection of early modern history and computational methodologies. Those of you familiar with his work will know he combines tools like GIS, data visualization, and text mining with traditional archival research in his field of interest, which is early modern Europe and the early modern world more broadly. He has contributed significantly to the study of freedom of movement in early modern Europe, and I commend to you in particular his 2020 book with OUP, Borders and Freedom of Movement in the Holy Roman Empire, as well as his more recent piece in Past and Present, which is also very, very much worth reading. Today, however, he's going to be talking to us on the topic of digital methods for an Emic history of climate. So, Dr. Scholz, Luca, the floor is yours.
Thanks so much for the invitation, Stuart, and for the introduction and for having me. Very much looking forward to giving a talk in this series. All right, let me share my screen. Can you see that? All right. Yes. Okay. Very good. Okay. So the talk that I'm giving today comes from my current main research project, which is an attempt to meaningfully engage with an environment that has been largely absent from spatial history and from the digital humanities more widely, and that is Earth's atmosphere. Now, recent decades have seen an increased uptake of digital mapping as a method of research in history and really across the humanities. And while we have seen that the methodological and also thematic concerns of the spatial humanities have really expanded in those years, most of the maps created in this domain visualize data of phenomena on the surfaces of land and sea. Now, this disconnect between atmospheric cartography and terraqueous cartography is by no means unique to spatial history, but it reflects a much wider division. The historian of cartography, Marc Momonier, once described the atmosphere as and I'm quoting him, as a province apart, invisible and largely ignored by those who study the design and the use of maps. So this is really something that we can see across fields. It is not just limited to the spatial humanities and to spatial history. Now, my current research project, which I'm drawing from here, builds on two strands of scholarship. One is what you could call the cultural history of weather. So this is a tradition of scholarship that makes an effort to diversify, to expand, if you like, to emancipate the study of weather and climate and atmospheric environments in the humanities. And the second strand of scholarship that I draw on is critical cartography and historical data visualization. And the key assumption in this line of work is that the arguments made by maps and other visualizations rely as much on the graphic choices that are made in the process of visualization as on underlying patterns in the data. So this is scholarship that has highlighted the screen as a site of work in which the humanities have an important mandate. And that is, I'm citing a phrase by Johanna Drucker. Other scholars in this field are Bill Rankin and Kelly Knowles, who have said very important things in this respect. And the key proposition that I want to make in this talk today is that by borrowing rather than forging their own visual language, the environmental humanities forgo a compelling mode of generating, of questioning, and of communicating their knowledge. And that a creative, careful consideration of the cartographic language used to present environmental data has considerable potential for enhancing the kind of scholarship that we do. I'll proceed in three parts. I'll first discuss the cartographic conventions that are found in meteorology, in climatology, and in climate history. I'll then discuss a more recent type of mapping that I found in historical scholarship that one could describe as algorithmic layering. And then I'll conclude with a case study from my current book project, which attempts to map weather as it was understood and as it was confronted by contemporaries in late 18th century Alpine Europe. So let me start with the cartographic conventions of meteorology and climate history. Now, meteorological and climatological maps constitute a broad, diverse, and sophisticated genre of cartography, and it's really impossible to discuss this in any depth in the time frame that I have for this talk here. So what I'll try to do is instead point out some of the shared visual conventions that showcase a physicalist vision of weather which detaches the atmosphere from its human environment. And I want to start with synoptic weather charts because these are perhaps the most common spatial visualizations that we encounter in historical climatology. They typically employ contour lines and depression tracks to plot atmospheric pressure systems and weather fronts. And they also use an established symbology to represent cloud cover, wind speed and wind direction, air temperature, barometric pressure, and weather conditions at specific times. Most lay viewers, however, will struggle to decode these maps' visual conventions, which tend to reinforce the exclusive expertise of climatologists and make these visualizations powerful rhetorical devices. In fact, some scholars of scientific graphics have argued that synoptic views of natural systems serve to imply that their authors have fully comprehended or even control a system. Now, synoptic weather charts are called synoptic because they display different parameters of Earth's atmosphere over a large area at a common point in time. And the variability of weather and climate over time is, of course, a key concern in the study of past climate. And climatologists do employ a set of strategies to map the fluctuation of weather and the variability of climate. What I found to be the most common way in which this happens is by which historical atmospheric cartography addresses time variance are small multiples. And you can see an example of this here on the right. So this is a map that I've taken from a book by John Kington, which contains thousands of these maps, where, like snapshots in time, maps are arranged in small multiples to show the temporal trajectory of weather and climate. So in this case, what you're looking at are the weather conditions on each day of September, the first half of September 1781, over the European continent. Now, by representing the atmosphere over areas of millions of square kilometers, these maps, or conventional maps of climate and weather, present weather as a phenomenon that transcends individual landscapes and places, and as a phenomenon that should be understood at the continental scale, if not at the global scale. And while this is often a direct reflection of the limited availability of, and granularity of data, the resulting maps contrast not just with how weather often has been observed and understood by historical subjects, but also with contemporary scholarship in the atmospheric humanities, which often understands weather as an integral part of the landscape. The perhaps most important characteristics of the maps that I reviewed so far concerns the way that they treat the atmosphere as detached from the world that it immerses. On synoptic maps, atmospheric events are commonly foregrounded against a dimorphic background that is structured by coastlines that bound land from sea. Atmospheric and phenological data, that is information relating to the seasonal changes in plants and animals, rarely make it onto the same maps. And even scholars who emphasize the interactions between atmospheric phenomena and events on the Earth's surface rarely make these connections visible. So that is the case, for example, with the work of Hubert Lamb, who does that quite a lot in his prose, but very much less so in his cartography. Now you can see one exception here. So this is an example where these rare interactions between the atmosphere and the non-human environment take a graphical form. And you can see, so this is a map taken from one of Hubert Lamb's more famous monographs, where he included in text comment that tells us something about the effects of weather on the human environment. Now, this is a characteristic that these kinds of maps share with the wider genre of contemporary climate change graphics, which are often primarily concerned with the biophysical environments and tend to elide human geography. And yet, recent decades have seen sustained efforts at realigning human and non-human history. Environmental history has found new ways of articulating climate-human interactions, for example, by focusing on social impacts or on the cultural interpretation of climate. So the question that I then wanted to ask is, are there cartographic strategies that avoid separating the human and the non-human geographies of weather? And that brought me to a second genre of maps that I want to show you here. Now, maps of historical atmospheric phenomena created in digital historical research today sometimes employ a different visual language than the maps that we've seen so far. And that partly has to do with why we resort to maps when we map. So in historical climatology, climate and atmospheric data are often the end result of a research project. Whereas in the spatial humanities, the emphasis is not always. There are projects that are primarily about recovering and generating new data, but in many cases, the emphasis will be less on generating new data than on exploring it in order to advance historical argument. And that translates also in the kind of visualizations, the kind of maps that scholars produce. Climatologists and climate historians tend to map atmospheric phenomena in isolation because it is primarily about the data that has been modeled or reconstructed in some way. Whereas in spatial history, in the spatial humanities, the kind of work that is done is predicated on the premise of merging different kinds of data. Now, the most important technique that enables this combination comes from, when it comes to atmospheric phenomena, comes from computational fluid dynamics, which is a numerical approach to model and to analyze problems involving fluid flows. So an example that I assume most people will be familiar with is, for example, modeling the aerodynamics of an aircraft. Now, of course, historical climatologists use these modeling techniques as well. But in historical and humanities scholarships, computational fluid dynamics is now used at scales of cities and villages rather than the scale of continents, in an effort to understand interactions between the human and the non-human environment. Let me give you a couple of examples. What you're looking at here is a visualization that I've taken from a fairly recent study by 3 economic historians who combined modern wind data with the location of industrial chimneys. They've extracted that information from Ordnance Survey maps to highlight the role of wind and air pollution in explaining the deprivation of east sides of former industrial cities in England. And the proposition is that the eastward direction of the prevailing winds push the industrial emissions into eastern neighborhoods. And you can see 2 maps here. These are overlays of I think about 70 cities in England. And the map on the left shows us the distribution, the model distribution of pollution. The map on the right shows us the markers of I think, yeah, well, in this case, demographic data on low-skilled labor. Let me show you another example that I found. This comes from an article by a Japanese historian, Muneyuki Natsume, who studied a model of a 19th century Japanese village with computational fluid dynamics to assess the effect that woodlands and hedgerows have on wind reduction in rural settlements that are typical of the time. And this research managed to corroborate some of the assumptions that historians, or some of the hypotheses that historians had formulated before, but struggled to substantiate without this kind of meteorological evidence. And let me show you a last example. This is again a fairly recent example. This comes from forensic architecture, where researchers in forensic architecture, as well as at UCL, used meteorological data and fluid dynamic simulation to investigate the exposure to airborne pollutants and chemical gassing of historically Black communities in Death Valley, Louisiana. So this is a stretch of the Mississippi River that's particularly heavily industrialized, particularly, I think, petrochemical plants. And so this was a project that tried to model the effects of that pollution on the communities that live along the riverbanks. Now, if the maps that dominate climate science and model-driven climate history, so the kind of maps that I've shown you in the first part of the talk, if those maps tend to eclipse or abstract human agency, the algorithmic maps that I'm showing you here foreground it. All 3 examples here employ computational fluid dynamics algorithms to show how human agents affect the atmosphere through landscape modifications and emissions, how they cause important, often long-term consequences for those living downwind. And at the same time, all 3 maps discussed here present the interaction of atmospheric environment and human society in what we could call physicalist terms. That means as measurable and computable as wind speeds and directions, particle concentrations, and fluid friction. Non-physical categories, so elements such as interpretation or emotion or experience, play no role in this map. Now, this emphasis on quantitative accuracy and statistical inference is far removed from the terms in which many contemporaries would have described their interaction with the atmospheric environment. So, as such, and borrowing the language of anthropology, we could say that these maps offer an etic rather than an emic account of the atmoterrestrial environment. That means they take a modern outsider perspective that reduces human atmosphere interactions to the physics of fluid flow. So the question then is, can we create maps of past human atmosphere interactions in an emic perspective? Meaning, can we map the atmosphere from an insider view as a social-political space that was understood and experienced in historically and geographically specific terms, rather than as a timeless, universal, and a strictly physical environment? Now, that is what I want to explore in the last part of this presentation. Now, what I want to introduce here is a case study that comes from a book that I'm currently working on. And that case study is the history of storm cannons in Alpine Europe. In the agrarian areas of 18th and 19th century Europe, hailstorms and other severe weather events could destroy the fruits and the crops of an entire season in a matter of minutes. Some of the oldest insurance models were designed to protect communities against the dangers of hail. But farmers also employed more active strategies against hail, such as ringing church bells, or also shooting at the sky to dispel clouds and avert what were often existential crises. Now, one practice that was particularly common in the Alpine region was to shoot at the clouds with empty cannons or rifles. The assumptions about the mechanism at work varied. So some people believed that the cannon shots could push the storm clouds away from fields onto forests and uncultivated land. Others suggested that metal bullets attracted lightning from the clouds and thereby caused them to discharge. And communities developed fairly elaborate tactics on where cannons should be positioned and when the shots should be fired. They also had often fairly articulate theories about which geographic features generated storms, which features attracted them. So lakes, for example, were assumed to exhale storms, whereas mountains attracted them. And this practice engendered heated debates among scholars, but not only, because in fact, it was not uncommon that neighboring towns and villages accused each other of having sent storms their way. Now, let me show you a concrete example of this from the early 1770s in the borderlands between Salzburg and Bavaria, so two principalities in what was then the Holy Roman Empire. Now, the situation is the following. The subjects of several villages and towns belonging to the Prince-Bishop of Salzburg petitioned their authorities to let them continue shooting at the weather after this practice had been outlawed a few years earlier. And the argument that made by these peasants in their petition was a spatial argument as much as was a spatial argument. So it is difficult to appreciate for readers that are unfamiliar with the region. So the map that I'm showing you here and the map that are coming are my attempt at visualizing the peasants' narrative. Now, the petitioners who lived in Holzhausen and in Ringham, and I'm not sure if people can see my cursor, but it's the two towns that we see at the center of the map. The petitioners who lived in those two towns, so in Holzhausen and in Ringham, wrote that the storms usually moved from two nearby lakes in the direction of a mountain called Teisenberg, but that they were always repelled by the strong weather blessings that were performed by the clergy in Högelwörth. This was a monastery of the Augustinian canons, which were considered particularly effective in their blessings against weather. The storm would then either stand still in the area around Teisendorf, or it would move towards their two towns, so those two towns of Holzhausen and Ringham, and then further towards Waldorf, Saaldorf, and Haunsberg, all areas in the Prince-Bishopric of Salzburg. Now, before this, the farmers argued, so previously, when they were still allowed to operate their cannons, the cannons that they fired in Ringham, in Holzhausen, and in Saaldorf had been able to either dispel the storm clouds or at least to direct them towards the mountain close to Teisendorf, where then the precipitation would fall into the forest, so uncultivated land, where they wouldn't cause any damage to the fields. But now that they were prohibited from shooting, the storms went back to take their old course. Now, the storm track that the farmers describe here suggests what one could call a billiard ball vision of storms, where physical and epitropic interventions, such as hail cannons, but also weather blessings, deflected storms from their natural course. So these interventions constrained the space within which the storms could move and determined their ultimate course. And this atmoterrestrial force field described by the peasants was informed by more widespread assumptions around the storms, assumptions around the interactions of storms with the terrain underneath. Exhaled from the lakes, drawn in by the mountains, and dodged by the weather blessings to the south, the storms could only escape westward into the heartland of the Prince Bishop of Salzburg. So the weather space that emerges from this petition was not just informed by contemporary beliefs about atmoterrestrial interactions and religious forms of storm suppression. If we take into account the political geography of the region, another layer emerges. The petitioners claimed that their precarious position was exacerbated by neighboring towns that were allowed to continue shooting. If we wish to understand their narrative, then we also need to take into account the political geography of the region. And that suggests a political explanation to the physical geography that was discussed in the sources. The cannons in Traunstein, they claimed, pushed the storms even more vehemently towards the petitioning towns of Ringham and Holzhausen. Also in Ostermeeting, which is a town to the north, which actually I did not include on this map, but it's just slightly beyond the map bound at the northern edge of the map. The shooters there, also to reference the petitioners, also do not let any storms across the water and thereby further lock the storm's path. So Traunstein and Ostermeeting, the shooting towns that lock the storms in to the north and northeast, were both situated in the electorate of Bavaria, in very close proximity to the border with Salzburg. The petitioners thus framed their use of the cannons as a question of self-defense against the Bavarian neighbors, as a type of argument, and this is a type of argument that we can find in many other similar cases. And in fact, it was successful. The petitioning farmers, and in fact all Salzburg subjects along the Bavarian border were eventually allowed to operate their cannons again, but only under condition that they only pointed their cannons towards Bavaria, so not inland towards Salzburg, but only outwards towards Bavaria. So I think what becomes clear here is that the atmoterrestrial geography described by the petitioners was informed by beliefs and by structure that were specific to their cultural and political context. And at the same time, we should be careful not to reduce the geography of these weather wars to cultural beliefs and political tensions alone. Because the physical tracks of the storms that are described here by the petitioners are in fact consistent with the region's climatology and the westerly and southwesterly winds that are characteristic for most hailstorms in the area. And let me show you another map. So for this, or to test for this, I obtained radar data from a Swiss climatologist. Was kind enough to give me some of the radar data they had collected on severe hail-bearing storms, mostly over Switzerland. And after an intense couple of hours, or probably a couple of days, figuring out how to transpose this data into a usable format in Python, I managed to display it on maps. And the data that I received includes the outlines as well as the centroids of storm cells that bear large hailstorms. That means those are storms that produce stones that are larger than 3 to 4 centimeters. So really the most severe category of hailstorms. And these are recorded at 5-minute steps collected over the last decades. So what you're seeing here is really only a selection of that data. It is only the centroids. So if we mapped the outlines of these storms, they would appear much broader. But I chose to map the centroids here because they show how the storms that contemporaries were contending with were these elongated, fast-moving shapes. And what the scholarship of climatologists, but perhaps also the small sample of storm tracks that you can see here, shows that most severe hailstorms in the Alpine region actually follow relatively linear trajectories. But some storms can occasionally take sharp turns and change directions that are very much in line with the kind of storm dynamics that are described by contemporaries.
Sorry, Luca. Sorry to
Yeah.
interrupt you. The image is a bit off center. Oh, that's much better. Now it's moved to
All
the
right.
center.
Is that better?
Yes, yes. Yeah.
Okay.
Yes, we
Sorry
couldn't
about
see
that.
the bit you were talking about right there. So that's great. Okay.
Oh, okay.
Just keep going. Thanks.
So yeah. Okay, so you can see, yeah, you can see the storm tracks now, right? So you can see some of these are follow fairly linear trajectories, but then you also have some that are yeah, that they take sharp bends and turns, and even the ones that are linear do occasionally take very sharp bends and turns. So all of this to say that what the petitioners described to us here in the sources actually is not as yeah, is perfectly in line with how these storms behave in the real environment, or in the environment as we can record it with technology today. To the petitioners, the irregular morphology of storms resulted from the interplay of human and non-human forces. And the juxtaposition of climatological data and archival narrative spotlights the extent to which these storms in the late 18th century were really socio-natural hybrids. Now, the contrast between this map that you're seeing here and the previous maps also underscores how atmospheric history can benefit from changing its scales of observation. Now, as we've seen in the initial part of my talk, conventional atmospheric cartography frequently privileges small-scale maps of entire continents or regions that leave little room for local detail. In fact, many of the maps are hemispheric or even global in their scale. And very similarly, modern climate science, with its strong emphasis on the global scale, has reduced geographically differentiated climates in the plural to one global climate in the singular, thus further contributing to the erasure of local experiences of climate. So what I would argue is that a reconsideration of scale is essential to a humanistic cartographic syntax that allows us to probe the cultural and the social-political dimensions of atmospheric environments rather than just their physical properties. Now, before I conclude, I just want to mention. So I mentioned that this is part of a larger book project, and in fact, the history of weather shooting did not end here. So in the late 18th and 19th century, authorities repeatedly sought to suppress the practice, and that was very much in line with wider reform efforts aimed at restricting forms of popular piety. But in fact, rural populations persisted, often to the point of staging violent revolts. And what I found is that storm cannons remained in use throughout the 19th century, and that they experienced a revival at the turn of the 20th century. And you can see, so you can see an example of locations. So at the moment, I'm doing the work of reconstructing this revival of the Hell cannons in the early 20th century. And you can see an example. It's not complete data, so the list that you're seeing here is somewhat incomplete. But what you're seeing on this map here are locations that had installations, often very large installations of hail cannons. Across Europe. And what is interesting, and also outside of Europe, and what's interesting is that while there was much more continuity than second wave storm artillerists care to admit, there were also some important changes in weather shooting. I won't go into that because I think it goes a little beyond the topic of this talk. But I just wanted to conclude with showing these maps that show some of this work in progress and some of the distribution of these hail cannons nowadays. And we can touch on that in the discussion if people are interested. All right, let me conclude then. Okay, so focusing on a chapter in the history of weather modification and taking a long view of how meteorologists, historians, and their collaborators have mapped atmospheric environments, I asked how Earth's atmosphere can be mapped as a social-cultural construct rather than as a physical process in the exclusive remit of science. And we've seen that the concerns of historical climatology have long favored a longue durée, flat, small scale, and also an isolating perspective on the atmosphere. By eclipsing or abstracting human experience and agency, these maps reflect and reinforce the separation of human and non-human features that has long marked historical scholarship on climate. We've also seen a couple of more recent studies which employ computational fluid dynamics to show how human agents have affected atmospheric environments through emissions and modifications to the built environment. And at the same time, these remain committed to a modern, we could call it a physicalist perspective that reduces human atmosphere interactions to the physics of fluid flow. In the last part of this talk, I show to you my attempt at a more human-centered cartography that attempts to represent past weather as it was understood by its contemporaries. And I think perhaps one of the conclusions that we can draw from this, or that I'd like to draw for this, is that visualizations of environmental data are often criticized as and can be sterile, totalizing. They can even be a form of planetary voyeurism, but they really don't have to be. And you've seen here my attempt at making a visual argument that bridges the split between human and non-human history, that tries to reconfigure weather as part of the landscape and take seriously the views and the understandings and the categories of historical subjects. Now, of course, digital mapping is no panacea, and the medium has obvious limitations. But I do believe that maps have an important role to play in expanding the remit of historical atmospheric mapping beyond the graphical repertoire of atmospheric science. And this is where I conclude for today. So thank you very much.
Wonderful. Thank you, Luca, for the very interesting and wide-ranging presentation. I don't think it's a topic that either in the history department or in the digital humanities talk series we've had addressed. So it's really it's fascinating to have something new and to hear about your new book project as well. So it is new in across a number of different dimensions. So yeah, I mean, we have lots of time for questions. So please, those of you in the audience, do feel free to type your questions in the chat. Do remember that you should address them to everyone. So there should be a little blue box, and it should say to everyone, so everyone can see the questions. But while you're all typing, maybe I'll sort of abuse my position here as chair to ask maybe an initial question. Um, I want sort of, I guess, towards the end of our discussion to move on to kind of general questions. And we have a couple of sort of set general questions we normally ask. But I'm wondering, could I start off maybe by asking you to say a little bit about your journey as a digital historian, digital humanist? I mentioned a few sort of landmarks in your bio, but I was wondering if you could kind of reflect as somebody who is certainly by their job title defined as a digital humanist, digital historian. I'm wondering if you could give us maybe just a flavor of your kind of experience and your journey to date.
Yeah, yeah, sure. So, so I started doing spatial history, so working with GIS for historical research during my PhD. So during the end of my PhD, because I was lucky enough to attend a course on spatial history, and it's not, I don't think it was something that I had considered before, but it was very useful for the work that I was doing then, which was about a history of the channeling of mobility in this very fractured space that was the Holy Roman Empire. So that is really how I started. Yeah, how I started working on that, and then I had a postdoc where I continued this kind of work, and then also started to do some text mining. So I've done a couple of I've done some work. I've published 2 pieces where I was looking at was mining the titles of dissertations written at German universities, which was something which is a genre that really is I think very suitable for distant reading method, simply because it's an archive that is so forbidding that it's way too much for an individual scholar to really to read it. And I think, to be honest, actually, I think a lot more work could be done with this kind of genre, both specifically with the German dissertations. There are just hundreds of thousands of them, but really also in other countries, and also with contemporary dissertations. And then, yeah, and then so currently, but then I think the main work that I do has always been, I think, fairly centered on historical GIS, on historical data visualization. I suppose what brought me to do the work that I'm doing here, so what I just presented here, so this interest in atmospheric mapping is partially this book project that I'm working on, which is to me also an opportunity to in fact extend the spatial remit of spatial history, so going into a different environment, going to atmospheric, going into looking at how, as humanities scholars, as historians, we can meaningfully engage with the atmospheric environment in ways that are perhaps different than a meteorologist or a climatologist would do it. So that is, I think, really the methodological interest behind that. I think the other thing that drives me there, or that made me really interested in this, is that I felt, and again, this is in line with work that other scholars have, things that other scholars have been saying for a while, like Johanna Drucker or Bill Rankin, and Kelly Knowles, about how there's a lot of concern in developing new ways of generating data and perhaps processing data. And there's been amazing work in digital history and digital humanities at large. I mean, so from people using computer vision, right, to for example, work with historical maps at scale, the kind of work that Katie McDonough is doing and colleagues. But also work on just large data visualization. But I always felt that the kind of maps that we were seeing in spatial history really hadn't changed much from the last 10 to 15 years. So there isn't in a sense, there was a lot of concern with what we could call the input side of digital history, digital humanities, and perhaps less so with the output side. And I just felt that, there's a lot of interesting and meaningful work to do on the output side as well. So that is why then I thought to emphasize the cartographic elements a little bit more. So this is also, I think, yeah, there's also, I think these are some of the methodological concerns that kind of brought me then to be interested in these kinds of questions.
And that's a very interesting observation about the input and output sides. I suppose, yeah, I guess upon reflection, if one thinks of a project like, say, the Stanford Republic of Letters, sort of multiple series of projects kind of brought together, that all my students will know because we study it. I mean, that sort of model for spatial history is, in some ways, hasn't been superseded. Rather, it's been kind of built upon and expanded. Um, and yeah, I can really see the value in kind of looking beyond, yeah, those sort of simple outputs in a sense, right? And kind of mapping at different scales, mapping different things, not just letters and people, but other sorts of things. That's really, yeah, I think that's very, very valuable. And so just maybe we have our first question asking about sort of the tools that you're using. So you mentioned I don't think you mentioned which particular Python library you were using, but there are some sort of relevant Python libraries. Our students learn QGIS. I mean, what else is out there, and what do you use in your day-to-day practice of your craft?
Yeah. Yeah, so I'm also a QGIS user, so that's also what I use in my own work and what I teach my students. So the maps that you've seen here, where the basic stuff was mostly done in QGIS. Some of the so when I was working with the climate data, that was done in Python. I think I've been using I think GeoPandas was what I used to do the some of the transformations. I mean, I do use some. Yeah, I think if students do have an interest in Python already know a little bit, then obviously that can be great to particularly to create interactive maps. But then if you don't have that background and you're not interested, there are other solutions. I mean, you can, for interactive mapping, ArcGIS Online probably is one of the options, and there's plenty of free solutions as well. I think one thing I should say is that, so for the maps that I've shown here, so most of these, I've started doing them in QGIS, and then I've kind of the more detailed design, if you like, I've
可以
done
吗？可以
Adobe
换吗？
Illustrator,
啊，
which
我不太
which
指定了。啊，
Oh, sorry. Who is that? Okay, I think they've.
okay.
Okay.
Unmute that.
Okay. Yes. Yeah. All right. I think we can continue. Sorry.
Yeah, right. Yeah, so basically obviously one limitation of QGIS is I feel like it's I think it's called the print layout editor or something, and it's terrible. So I think if to make those maps look somewhat better, than continuing that kind of work in Adobe Illustrator or free alternatives. I think Inkscape, there's plenty of free alternatives as well, is a good idea. So I would say these are some of the main tools that I used in this case. Tableau is something that I also use quite extensively, and that I also use in teaching. But I think it's really, so if the question is how difficult it is to use those tools, then I don't think depending on which ones, not very much at all. The learning, depends. Some maybe take a little bit more learning, but I think mostly everything is rather accessible.
Great. And so we have another question here, sort of moving on to the issue of data. So Christy asks, is it hard to obtain the digital archives of climate data? What's the biggest challenge?
Yeah. I mean, yes and no, because obviously historical climatologists have done amazing work in collecting historical observations and inserting them into these huge numerical models. I think they're called reanalyses, where basically they use weather forecasting models to kind of forecast the weather of the past based on limited set of observations in the past. And that data is all publicly accessible. Some of it can be technical, so there's a lot of more technical second-order metrics that maybe if you don't have a background in climatology or meteorology might be tricky to understand. But if you're looking for basic information like surface temperatures or perhaps windiness or perhaps pressure or also then those at least at smaller scales, that means over larger areas, that kind of data is there's plenty of that. Now obviously a lot of that will be model data. If you're interested in historical observations, there is quite a lot of that as well, and so there's different initiatives. There's obviously the CLIVOC database that I think is largely collecting observations from logbooks of ships. There is initiatives like the European Severe Storms Laboratory, so they have put together a database of historical storm observations over Europe. So it depends a little for where and when you're looking. I would say probably the further back you go, the more you will rely on model data and the more uncertain that data will be. And also, obviously, if you're looking for different parts of the globe are obviously represented in very, very unequally and very unevenly in those data in ways that reflect immediately also the history of the records that we're using and the history of those regions, as you can imagine.
Yeah,
I mean that much maybe about. So sorry, that just if I may add that much about quantitative climatological, traditional meteorological data in the sense of measures of weather. Obviously, if you're interested in the kind of I don't know, more qualitative observations or the kind of things that I've used here. Again, I think there's plenty, and I think there's quite a lot of interesting work that can be done in combining those two. So looking together at the kind of quantitative data that climatologists and meteorologists are interested in, and the kind of qualitative data that historians more are perhaps more familiar with immediately.
Yeah, that makes sense. Yeah, and I'm very interested in this CLIVOC, is it called?
Yes, CLIWOC.
WOC, okay. CLIVOC, okay. Made a note of that. Yeah, maybe we can take a look at it in class in a couple of weeks. Yeah, so maybe sort of following up on that before we move on to the other question in the chat. So I mean the kind of units of analysis, you've talked about how different parts of the world are sort of represented differently depending on the kind of richness of the historical record. And I guess kind of connecting to you mentioned kind of critical cartography before. And I'm wondering about, you used a very interesting term that our students may not have heard before, which is Alpine Europe. And I'm wondering how your kind of your choice of, was it meta geography, as it's the myth of continents, right? That book. How your sort of meta geography. It's quite micro in many ways, but you do have this kind of interesting unit, Alpine Europe. I guess it relates to kind of the uniqueness of the climate versus some other part of Europe, presumably.
Yeah, I mean, I think there's definitely. I mean, I use Alpine Europe because the area that I cover in my book is basically what you saw on those maps before. So it's mostly the peri-alpine, the alpine perimeter, essentially. Sometimes within the Alps, but really mostly it's at the foot of the Alps, but really all around. And that is why I use this term Alpine Europe. But yeah, I mean, it's ultimately it's a reflection. I mean, there's a cultural element to this, where there's an economic history that kind of determines that geography, but there is of course a climatology that is very specific to this part of Europe, which is conditioned by what meteorologists call orographic precipitation. So that means that what happens is that you have these air masses that are pushed onto the Alps by wind, and then they're elevated, and while going up, they cool down. The water condensates, and that causes a lot of these hailstorms that we see in these areas. So if you look at, I don't think I have a map here, but if you look at a map of hail distribution, the frequency of hailstorms in Europe, then there's very much there very much is a distinct, yeah, the frequency is much higher around exactly in this area that I'm studying. So yeah, you could maybe that's something to think about to determine. In a sense, there is an environmental, it's an area that is very much united by a climatological commonality, if you like. And I don't. It's not necessarily something that perhaps that contemporaries articulated very much. It's something that comes out very much from the maps that I use. But there's also, I think, an interesting there's an interesting geographical imagination among contemporaries as well. So particularly also in the 18th century, there's a very distinctive methodological political imagination that comes out from these sources, which again is interesting because I think it connects also with contemporary concerns around geoengineering, around weather modification, and kind of how these inform and are informed by different forms of geographical imagination.
Yes, and that was actually going to be my next question. So I mean the shooting cannons into the sky made me think very much of kind of cloud seeding and making the skies blue in Beijing and all that sort of thing. I mean shooting into the sky doesn't really work, right? Am I correct in making that statement?
I mean, I don't know if it works today. It certainly did not work at the time.
Okay. But they were not entirely wrong, I guess, in at the level of theory at least. But okay, and modern cloud seeding, I actually don't know how that works, but it's.
Yeah, I think it's. I mean, it's part of the same. You can definitely see this as part of the same lineage of in the history of weather modification. And James Fleming wrote a fantastic history of the history of weather modification, and you can kind of see the continuities that you have in these various different attempts. I would say probably the main difference with contemporary or 20th century and 21st century efforts at cloud seeding is that these were all ground-based efforts. So there were some farmers effectively started using rockets. So there's a slightly more reasonable argument that you can make about how this can actually affect the clouds. I think many of the rocketeers at the time did not go anywhere as high as they would have needed to. And I think nowadays this mostly happens by, well, I think there are probably different methods, but I think one of the methods that are being used is for cloud seeding is injecting silver iodide into clouds from airplanes.
Okay.
So that is there's a very different it's a very different technique, and I think it's out of the question that any of these cannons worked at the time, but that did not stop contemporaries from being very much convinced that or at least trying to convince themselves in very interesting and absolutely fascinating ways that they did actually work. So what we see there is really a firework of imagined agency and attempts to read human agency in the sky. But it's very.
They didn't. Okay, great. So we have a couple of questions which I guess are a little bit more practical. So maybe I'll sort of summarize them to some extent. So the first one is kind of interested in this question of the relationship of kind of historical study to science and modern science. And a lot of environmental history is at this kind of intersection. I'm wondering if you have any sort of reflections about sort of your position in this liminal space, as it were, between the kind of traditional textual historians and then people doing, I mean, kind of what we might describe as something more kind of strictly scientific.
Yeah. Yeah, I mean, yeah, I think it's I mean, it's not a new, it's not a new tension, if you like, or it's not a new dimension, but I think this goes back very far. So especially in climate history, I think, I, yeah, I think there is a division. I'm probably not the best placed person to tell that to tell that story, but I think there is a there's a strong, there has been a growing division, perhaps in a sense, between scholars that are trained in history or more philological humanities disciplines, and then on the other hand, scholars trained perhaps in geography or more quantitative, statistical, or physical sciences and the kind of work that they do. They produce different types of scholarship to an extent, so different types of maps as well. In fact, the scientifically trained ones produce many more maps and rely much more on visualization than historians do. And there's fascinating, there's a lot of collaboration, of course, and I think this is something that we're seeing more of. So I think it can be a very fruitful place for collaborations. So I'm also in a in a project now. We're trying to get funding for a project. We're also collaborating with a climatologist, for example. Also working with historical shiplock data. So I think it can be a very exciting space. And I do actually think that, as you say, Stuart, as well, I think you're right that the digital humanities, digital history, are actually uniquely well positioned to play a role in that space, because we are used to mediating between the classical work, the perhaps more logocentric or text-based work, more philological sensibilities of historians and of humanities scholars, and the more data intensive, perhaps also more technical concerns of that you see in the sciences. So I do think there's potential for lots of interesting work.
Yes, and in fact, I think it was either the first or the second talk in this series a couple of years ago. We had Dan Smale talking about his own work, but also the work of Mike McCormick in the Science of the Human Past project at Harvard, and that's very much a kind of philological historical study plus scientific research. But I mean, looking at a kind of that sort of larger scale you discussed at the beginning, I guess, looking at the whole Mediterranean or kind of Europe or the whole world, and climatic change over a millennium or so, basically. And yeah, the interesting thing there was the collection of these ice cores. I think that's what I remember from that talk, and that's something that he had some of his graduate students do, which is not something one normally associates with, his historical study. But that's good. It's good. It's good. There are these sort of cross pollinations. So maybe we'll go for another, I guess, 10 minutes or so, if that's okay. And there, I don't see any more. I don't see any more questions in the chat.
I think there was a question on collecting data of climate, if it's easier for scientists. Do you think with the help of data, is it possible to reduce the impact of natural hazards in the future? Well, I mean, that is probably a question. I think there's a lot of interesting scholarship that is done. Again, I feel perhaps more by the social sciences than by the natural sciences, but unfortunately also more than by the humanities on on climate change mitigation, on mitigation of severe weather impacts. I think it's definitely there's a wealth of interesting and great historical scholarship. But it's perhaps my sense is that perhaps it is less a question of collecting data than a question of societal resilience, right, and mitigation. So perhaps this is again something. Yeah, this is again maybe a question that isn't so much about necessarily quantitative data than it is about, for example, writing histories about climate variability and societal responses and resilience in the past. And there's a wealth of scholars in history across the humanities who do fascinating work on these topics.
And maybe related to I guess this sort of collaborative sort of dimension. So the particular project you have at the moment, I guess, is in a sense traditional historical monograph in that you are the single author. Although using sort of data and material collected, by people in a number of different places and fields. My impression is though that spatial history does tend to come in these large collaborative projects. Am I right? As this is a kind of often a contrast people draw in the digital humanities between the lone humanities scholar and the more collaborative digital humanist.
Yeah, for sure. I mean, this project. The book that I'm writing will be a single authored monograph. But I do also collaborate with others. So I'm working with I've been working with two student research assistants, and we're in the process of designing a website that makes some of the data that is being generated in the project available to a wider public and kind of to make it interactively explorable. So there is, and that is work that is by its nature collaborative. I think, to be honest, part of the so I do agree that most of the best spatial history work tends to be collaborative. That's often, I think, also simply a function of people not one single person having the skill set required to do all the work that is involved in these larger projects. And I mean, I would think probably even the larger projects that are very visible of a more monographic nature, if you look at the list of collaborators, you'll see that there's loads of people who have collaborated on them. I think one of the, and it's not news, it's a well-known limitation. It's part of the way that the kind of scholarship that is expected, perhaps particularly by historians, where the monograph, at least in the UK, still reigns supreme. So I think there's a lot of, there has been a lot of progress, I think, in making collaborative work more recognized, but I think there is still a long way. I think there's still a long way to go. And I know that the American Historical Association has, I think, a couple of years ago, has issued some guidelines on how to assess collaborative and also projects that don't take the form of a monograph, of a journal article. And I think that is super important. So hopefully there is some progress. That is something that we can see more of in the future as well.
Yeah, no, Hong Kong is in many ways still follows the UK model with the RAE, and books can be double weighted. So we are also pushed into the direction of books, certainly on the humanities panel. So see, we have system. Yes, and it changes in lockstep with the UK system. So we're still actually part of that. So we have another question here. Can you see it?
Yeah, I can see it. So it says, I assume that these historical maps were primarily for predicting weather in the short term. If so, I wonder that against the current, more challenging shifting situation of climate change, does the current technology of mapping weather increase the accuracy of weather predictions? Well, I think, I mean, yeah, I think there's perhaps two questions here. I think one question is about the is about to what extent we can use contemporary data to make inferences about past weather, and I think that's a problem that's only going to become more acute as we go on, as the climate continues to change. I think it's very specific to what you're studying. So I think in the case of the alpine hailstorms, those are mostly caused by the interaction between atmosphere and the terrain hasn't changed much. So I think it's fair, as long as you don't make precise assumptions, as long as it's about, for example, generic conclusions about the kind of shape of storm tracks, I think it's fair to do, but it is a challenge that you have to keep in mind. That all studies that use contemporary, modern day methodological and contemporary data, and I think pretty much most of the examples that I've showed here do that. So this is definitely something to keep in mind, and is definitely certainly a challenge, and in some cases might present serious difficulties. Then the question of current technology of mapping weather increases the accuracy of weather predictions. I mean, to be fair, I think the weather prediction is primarily a numerical exercise. So the visualizations come after the fact, and I think I think certainly there have been incredible improvements in the kind of models that have been used for this. For weather prediction, I think the question of how we map weather forecasts, or how we map weather, not just in historical scholarship but also today, is a super interesting one. So I'm trying to collaborate as well with a meteorologist on recovering some of the traditions of weather mapping in the past, because I think again there's a very interesting history there. But there's certainly I think there's certainly a very a fruitful field of scholarship that I think we'll also see some interesting work that then in turn might also be interesting for historians of climate and of weather.
Mm-hmm. Yeah, so looking, I guess from the past to the present to the future. So you've given us a sneak peek of your book. Could you tell us a little bit more about the kind of the larger, I guess the larger sort of project of the book, and where what you've presented today fits into that?
So the book is a history of this big weather modification effort from the 18th century to the early 20th century. So the part that you've seen today, the case study that I've shown you today, that will particularly sit within one chapter, which is in a sense the earliest chapter of weather modification. The use of these canons goes back significantly earlier. So at least the early 1600s, probably earlier as well. But really, we start to have a rich archival record for these only then in the 18th century, that then allows to conduct this kind of research. And it goes forward. And I think what I'm interested in particular with this project is to tease out the shifting relationship of these farmers engaged in weather modification with the atmospheric and terrestrial environment. So what I notice is that there is strong continuities. I mean, these canons, they change a little bit, the make of them change, they look a bit different, but fundamentally they do the same things. But the way that there's other continuities, but the way in which these farmers organize themselves, the way in which they think about the activities that they're doing, the language that they use to describe it, changes dramatically. And I think that in turn then tells us something. So this shifting environmental imagination also tells us, and shifting spatial imagination, and not just imagination, also the concrete spatial practices that they do, tell us something about wider changes that are happening in this area at the time.
So you're going to be, I guess, doing archival research on the later periods as well, and putting together kind of case studies,
Yeah.
even beyond, let's say, the early modern period conventionally understood.
Yeah, because I think because I think the story requires it. So in part that is novel territory. That is novel territory for me as well. But that's also what partially makes it exciting. But yeah, I think it's a story that really goes across those periods, and I think it's worth telling it as one story and not chopping it up.
Mm. Yeah, and I guess related to that. So I mean, you're someone who's kind of pushing forward the boundaries of spatial history. I mean, where do you see the field going? I mean, we talk about this spatial turn in our kind of historiography class. I guess we date it to, I don't know, 20 years ago or 25 years ago or some, in the recent past, certainly. But where do you sort of see it going and its relationship to digital humanities? You're kind of moving away from the, how do you describe it, the aquaterrestrial to the
Yeah,
lower atmospheric.
Terraqueous. Yeah.
Terraqueous. There we go. Had the wrong way around. So I guess where do you see the next frontiers, or where do you see things going in maybe the medium term?
Yeah. Yeah, I mean it's a good question. I'm not sure I have a good answer, but I think some of the work that what I'm definitely seeing is some very interesting work in, for example, applying computer vision technologies to large map collections. So for the
Mm,
purpose of feature extraction, but also all kinds of other analysis. So I think that is very
mm,
much that is certainly some of the most forward-looking work
mm.
some of the most forward-looking work that I've seen. I think
Do you have an example of that that students could look up?
yeah. So there's a project called it's called Map Reader.
Map reader. Okay. Note of
It's
that.
so this is something and there's a colleague Catherine McDonough who is I think who's leading that, and so that's a very interesting project. That is
Mm,
something that I think is very interesting. I think also that I think perhaps we might see more cartographic work, more compelling cartographic work in the spatial humanities, which is perhaps also a function of scholars appreciating this as an important part of the kind of scholarship that we do. So I think there's a number of projects. I mean, certainly I would hope that we would see more scholarship on climate and weather coming from this field. So I'm also involved with other colleagues in a project where we also try to work on develop a larger grant bit on weather as well. So I hope, so I think these are some of the areas that I see where I see I don't know, a lot of movement, or where I think things look things look quite exciting.
yes, and but yeah, I'm sure we will. Uh, maybe in a couple of weeks in my class, students, we can take a look at this map reader. We're going to have a week on computer vision, so that will be something maybe um, nice to look at as well. Great. So, I think maybe we'll just wrap it up here. It was a really tremendous presentation and a very interesting discussion. Thank you to everyone who contributed questions. This is, in fact, the last meeting for this term, if I'm not mistaken, Basma. We don't have any more.
We have one in person.
Oh yes. Oh yes. Okay. And the date of that is
12th of May.
12th of May. Oh yes, much later. So after the end of term, and that's Simon Mahoney, formerly of UCL and Professor Emeritus at UCL. So we're taking a break in April, and then we will be back in May. So I guess all that remains then is to thank our speaker once again for his tremendous presentation, and thank you to you all for coming. So
Thanks so much.
good afternoon, good evening, good night, wherever you happen to be in the world. Okay, bye everyone.